Hello everyone, this is a video for Math 180. I'm gonna do a problem from Assessment A in section 10.2 about displays. And I'm gonna do the problem in the book, and then I'm gonna do a couple other displays just to show it. So the problem is this: sixth grade students report the number of apps that they downloaded to their smartphones. Results are given below. And then you've got this long list of actually 25 values. And the problem was to construct a dot plot. Okay, so let's go ahead and do that. And then I'll move on to, thinking about other things such as stem and leaf, histogram, and pie chart. Again, dot plots are really good with the younger kids because there's a sort of easy one-to-one correspondence between the values and the dots. They're easy to construct, and they give a nice display that you don't have to worry about bins or anything like that. Basically, there's a value for each value in the range. So you kind of have to know what's the low and what's the high value here, sort of the extreme. So here the lows are zeros. Those might be kids who don't have smartphones. And the highest one, looking through, I think is the 25. So we're going to need a scale that has every value from 0 up to 25. Okay, what I like to do is to just use lined paper and turn it sideways. That usually, that often works really well. I'm going to start over here. So this double red line, that's my scale line, and I'm just going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I'm just crossing my fingers here, hoping I got enough, and I do. Just squeak through. So I've got a scale that goes from 0 to 25. I'll draw in the line. Okay, and now dot plot, given its name, is you put a dot for each value, so that it's kind of like a stacked, kind of like a pictogram, or a bar chart. So the nice thing here is you don't have to reorder them first. So it's easier for the kids. They can just do it in the order that you see. So you can go. And the other thing I like about doing this is you want your dots to be roughly the same size. So if you do it on paper, you can kind of see the lines underneath. So I can make my dots all about the same size. So 12, 5, 7, 3. The sticking points you'll see with kids is when you have to start stacking. So I got 2, and now I got this other 0. So now you just stack them like that. The other thing is, get them to make their dots all pretty much the same size. Now there's technology, Tinkerplots, and some other things that'll do this for you. Make sure you don't double zeros. Make sure you don't skip any. 15, 17, 25, that was my high value, 7 and 8, 10 and 12. And then I've got 13, 2 more zeros, 10, 14, and another 0. So that's the basic dot plot. However, you need to label your axes. So this is number of apps. And you also should have some sort of title here. So I'm going to write 6th grader, 6th grade grader phone apps. Okay, and so that's basically all you need: a title, label your axis. You for a dot plot, you have every single value, right? So you see the gaps. You see like this big gap. We've got nothing for 18, 19, 20, all of those. And you see all these little gaps. And you also see stacked up for frequency. It's nice to kind of ask them some questions, about it. So, you can kind of ask them, why do you think there's so many zeros? Or how many kids had 0? And, that would give them 7. So kind of the number. But then kind of why, again, oh, well, there's a lot of kids that don't have a phone. That kind of thing. Or their parents lock their phone so they can't download apps. That's another thing, right? Another thing is to see sort of the shape. Is it sort of even? Is it a bell shape? Is it a sort of ski slope? And it's kind of, it's got this ski slope, but then there's a little bit of a bell in the middle. So it's kind of interesting. You have sort of something going on here. A lot of people at 0, one person at 25. If you ignore those groups, then it's like a bell curve. And so that's, a nice way to kind of see it. Overall, though, it's a little bit more like kind of a ski slope with a bump, with a model. Okay, so that would answer the question that was on the, what do you call it? That was in the section. So now I just want to kind of do a little bit more than they asked. So use this as an opportunity to do some other things. So let's think about a stem and leaf. If I wanted to do a stem and leaf for this, okay, well, you can go right back to the data and you need to kind of figure out what are your stems. So the most natural stem is place value. So it's a nice, kind of reemergent on this. So it's slightly older kids, but you start to use place value. So we've got zeros, we've got 10s and 1s. So I'm gonna make something where, here we go. These are 10s and these are 1s. And I've got this dividing line. Now I go from 0 up to 25. So I just go 0, 1, 2. Those are the only stems I need. And then you make a leaf for each value. So you just kind of go through 12, that's 1, 2, and then 5, that's 0, 5, 7 is 0, 7, 3 is 0, 3, and then a 0, 0, a 0, 2, a 0, 0, a 1, 0, a 1, 2, a 9, a 0, a 0. Try to space your leaves out roughly equal. 17. Now the 25 is down here. And then a 7, an 8, a 10, a 12, a 13, a 0, a 0, a 10, a 14, and a 0. So notice these aren't all in order. Sometimes people want to rearrange them so that the stems are all low to high. If I wanted to do that, you don't necessarily have to do that, but some people like to do that. So you have to go, okay, I've got 1, 2, 3, 4, 5, 6, 7 zeros. And then I don't have any 1s. I have a 2, 1, 2, and 1, 3. And then I have a 5. Looks like 2 7s, an 8, and a 9. And then with the stem for 10s, I have 3 zeros, and then I have 3 2s, a 3, a 4, a 5, and a 7. And here I just have the 2, 5. Okay, so both of these, here, this would be 10s, 1s. They need a title. So, sixth grade phone apps. So same title for either. So both of these work as a stem and leaf. whether you just do them in the order they occur or you rearrange them from low to high. You might slightly prefer this, but it's a little bit more work. Okay, the nice thing about stem and leaf is you don't lose any of your data. It's confusing for kids because, there's each of these, like this 2 is not a 2, it's actually a 12, right? Because the stem has to go with each value. So this 5's a 15, this 5's a 25, and this 5's just a 5. So, the 3 leaves that are 5 all are actually different values, either 5, 15, or 25, depending on what stem they have. So that can confuse the kids until they get sort of old enough to understand. What are some other issues? Oh, a benefit, again, between this and, say, a bar graph or a histogram is you have each individual data point. If I lost my list and only had the stem and leaf graph, I could reconstruct my list. I could make my list back over again. And the same thing also with a dot plot. The nice thing about a dot plot is you still have every single value represented uniquely. So if I lost my data set, I could reconstruct it from the graph. So that's a nice aspect. Notice how kind of different they look. This looks really kind of spread out with this big lump at the beginning. Look at this one. It looks just much more kind of ski slopey. Okay, so you might think, which one's better? Depends on the age of the kids, depends on the context, and some other things. So let's think about a histogram. So a histogram is a type of bar graph. And you can just kind of turn a stem and leaf sideways and turn it into a histogram. Basically, I would have a histogram that's got one bar like this, one bar like this, and one bar like this. But I would, instead of calling this 0, I would call it 0 through 9. Instead of calling this 1s, I would call this 10 through 19. And this would be 20 plus, anything more than 20. Okay, so you can make a bar graph from a stem and leaf, just sort of turn it sideways, and shade in your bars. But it's not always the best bins. So here, because it's a little bit too compressed, let's make a histogram where we have some more bins. So 3 is really on the low side for a histogram. Usually it's like between 5 and 15 different bars. So let's try that. So the first thing you usually need is a frequency chart, and where you decide sort of your bins. So my bins, instead of going 0 to 9, 10 to 19, and so on, let's do it by 5. So let's do 0 to 4, 5 to 9, 10 to 14, 15 to 19, and then 20 through 24, and then I have a 25, so I'm going to do 25 plus. Okay, so now my bins are sort of a value of 5. Now, the last bin, you can say plus, and it's just anything over that. But all your bins need to have the same number of possible values. So notice 0, 1, 2, 3, 4. They each have 5 different values in it. Okay, and then you put the frequency comes next. So how many times each of these happen. Sorry, my hand keeps sticking. So let's take a look at our dot plot, because it's basically a compressed dot plot. So how many times do I have between 0 to 4? 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9. How many do I have from 5 to 9? 1, 2, 3, 4, 5. How many do I have 10 to 14? 1, 2, 3, 4, 5, 6, 7, 8. How many do I have 15 to 19? 1, 2. 20 to 24, I don't have any. That's 0. And 25 plus I have 1. Okay, so it made, this is a frequency table. And the important thing here is, you choose the sort of width of your bins, and then how many fall in each of those bins for the value. Okay, so once I've got my frequency table, I can make my histogram. So a histogram is just a frequency table. Oh, I'm sorry, it's a bar graph, but the bars fill up the whole width of the bin. There's no sort of gaps between bars. Okay, so let's, and your bar should all be the same width. Again, I like to use a piece of paper, and then I'll put this piece of paper underneath, and then I can sort of see through. It kind of makes it look a little bit like wrap paper. Okay, so I have 1, 2, 3, 4, 5, 6 bins. So let's make 1, 2, 3, 4, 5, 6 spots for bars. Okay, in my scale, I go up to 9. So how far up? So I'll go like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so on a histogram, the vertical scale is always frequency. Okay, so now I've got 0 to 4, 5 to 9, 10 to 14, 15 to 19, 20 to 24, and then 25 plus. 0 to 4, I've got 9 of them, so I'll make my bar here at 9. Again, it has to take up the whole width. 5 to 9, I have to go to 5 right here. Sometimes people, write the number on top. You don't have to. 10 to 14, I have 8. 15 to 19, I just have 2. Notice 20 to 24 is 0. There's no bar, so there's a gap, and then 25 plus is 1. Okay, so this is number of apps. Again, this is always frequency, and table 6 graders, phone apps. So just get in the habit, and again with the kids, for communication of the display, you want your axes to be labeled, and you want a title. You use a legend if if it's an appropriate situation for a legend. So this is a histogram. Again, it's a bar graph, but the bars touch each other. And usually don't need to know this, but the reason histograms have that rule, the bars touch each other, is then you can kind of use the area under the bars as a way to measure what's called the distribution. So when you think about like making it into a smooth bell curve, or this is a little bit more of a ski slope, maybe a F distribution. That's an easier thing to do if there's no gaps. So it's kind of for a technical reason, I guess is the right way to say it. Okay, so that would be a histogram. Now, I could have made the histogram with different bin size. You get to choose. The general rule is you want to have enough bars that you feel to see the shape of the distribution, but not so many bars that it's cluttered up. So usually between 5 and 15 bars is best. But sometimes you'll go as low as 3, and sometimes you might need more than 15. A lot of these sort of rules for displays are rules of thumb, right? They're not written in stone. They're sort of, you know, best practice kind of ideas. Okay, so what did I say we were going to do? I said we were going to do a dot plot. We did that, a stem and leaf, and a histogram. So now let's think about a pie chart. So pie charts are different than the other ones because they're based off of percentages. So go back to the frequency table, and we have to make a new column for, well, two new columns. We need percent and we need angle. So to find the percent, it's just 100 times the ratio of this over the total. So if we add these up, again, it's 25. So there's a total of 25. So this is 100 times 9 over 25, and so on. 100 times 5 over 25, and so on down the road. Notice the 25 is always going to cancel with the 100 and make 4. So it's 4 times 9 is 36. This will be 4 times 5 is 20. So this will be, just in this case, because there's 25, I can just multiply each of these by 4. That won't always happen. Okay, so that's the percentages. So notice roughly, oh wait, this is 32. I know how to multiply by 4, double it, and then double it again. 8 doubled is 16, 16 doubles 32. Okay, these should roughly add up to 100. They may not add up to exactly 100 due to rounding, but I think in this case they actually do add up to 100. So it should be, you know, basically 100%. So you can double check that. 36, 56, 86, 88, 96, 100. So this one's exact. Won't always be. Okay, now how do we figure out angle? Notice, and that's in degrees. Notice if you have it as a percent, then you can just sort of figure out, well, how many degrees is 1%. So you're kind of thinking of, here, let me get a piece of paper. So I can kind of go, okay, 1%, 1 out of 100 is how much of 360, right? Because there's 360 degrees in a whole circle. So if you solve this little proportion, 360 is 100x. X is 360 over 100, and that means x is 3.6. So that means if I have it in percents, I get the angle just by multiplying by 3.6. Now, if you wanted to do it from here, you'd have to do something else. But that's the advantage of going to percents first. Then you just multiply it by 3.6 to get your degrees. I'm not going to show you my calculator. I've done this all. And this is rounded. But if I do that and then I round it, this is 130. And again, this is degrees, 72, 115, 29, 0, and 14. Now this should add up to 360 degrees. But again, it's only approximately because there's some rounding. This one, it actually does add up to 360. That just means the number of times I rounded down kind of equaled the number of times I rounded up, kind of idea. Okay, but now here's the fun thing. How do I make the pie chart? Bum, bum, bum. Let's do it. So first you gotta have the pie circle. I'm using my handy dandy cup here. Now, first problem is if I use a cup like this, how do I find the center of my circle? So I'm going to show you a trick From geometry that we may or may not talk about when we get to geometry, take a piece of paper that has a right angle and put it so that the corner of the paper is right on the circle. And then if you do that, then it will be the case of the other two spots where it touches the circle, that will make a diameter. And so once you have a diameter, you can just draw the line and go halfway. That's the center. So I got my ruler here. It looks like it's 4 inches and an 1/8. So if I go 2 and a 1/16 right there, that's my center. Kind of cool, huh? You can just approximate the center. You know, you don't have to do it exactly. So let's now do our angles. So our first angle was 130. So I'm just gonna start it like here. Need a reference. Now to do 130 on a ruler like this, you just line it up, center in here, line this up with 0. So now I'm gonna think of my angle this way. So I need to go all the way, I'm using the bottom numbers, all the way up to 130, 110, 120, 130. Make a little mark, draw it in. That is, now I could do different colors and do a legend, but I'm just gonna write in here. That is my 0 to 4, which represented how many percent? 36%. And notice it's roughly 1/3, so that makes sense. Now I need to do a 72 angle, so starting here now, I got it at 0, and I'm using the bottom numbers because I'm going this way clockwise. So I go up to 72, 71, 72 is right about here. And that is my 5 to 9. And that represents 20%. Okay, moving on. 10 to 14 was 32%, 115-degree angle. Line up 0. Go, sorry, I already forgot, 115. 115, line up at 0, go 110, 115 is right here. So again, because I'm going clockwise, I'm using the bottom numbers. If I was going counterclockwise, I'd use the top numbers. Now I have a mark here, but don't confuse myself. Those were the marks I just used to find the center. Okay, so this is 10 to 14, and that was 32%. Okay, and now I have a 29-degree angle. Here's 30, so it's just a little bit under 30, right there. That was not very well drawn, but you get the idea. That's 15 to 19, and that was 8%. Notice here there's a 0%, so a lot of times they'll just note right here, 20 through 24, 0%. It's basically this line. Has no area. And then this last one is hopefully 14 degrees. Yeah, not too bad. A little off, but not too bad. That would be 14. Oh, it's almost perfect. And that's the 25 plus. And that was 4%. So that's my pie chart. It needs a title. If I didn't write the percents in here or something like that, I wouldn't, like if I colored them different colors, it would have a legend. But since I put the data on the chart itself, I don't need a legend, but I still need a title. Something like that. Okay, so we got a variety of displays, all for the same data set. The easiest for kids to make is the dot plot. The most common, well, I don't know about most common, but there's stem and leaf. There's histograms, and you can also think of a frequency table as a display. It's not graphical, but it's a numeric display. And then the pie graph. Again, you might ask, why do I think of this as a display? It organizes the data. So just the data set at the beginning isn't really a display, right? It needs to be organized in some way to call it a display. So it can be the graphs, it can be the table. There's a lot of technical things on how to make a pie chart by hand. But the one thing to notice about it is some of the things you're doing are proportional reasoning. And then you're using some geometry. So it's kind of nice because those are other topics. So we're thinking statistics, but in making a display, often you're using some geometry, you're using some number in operation. So it's a nice way to kind of touch more than one standard, more than one area all at once. Okay, so this was a video for Math 180, section 10.2. Thank you.